Okay, hello everyone. This is Dr. Jenkins. This is going to be a video to review the lab that is finding the center of gravity. I have to admit, this is probably one of my favorite labs. I hope that you don't find it too terrible, and I think you won't. Okay, so we've talked about in lecture the center of gravity and how that's important in many activities. Sometimes you want it to be high, sometimes you want it to be low. Well, what we're going to do is you are going to be given a picture. So I'm going to assign you a picture, and I've got random activities. And you are going to calculate by hand the center of gravity for your given picture. And just like everything that we've been doing before, I'm introducing things that you're going to be asked to do for your lab assignment, your lab project. So as I keep saying, you're going to be choosing an activity. You are going to break it down into 4 phases. And what I'm going to show you how to do is create kind of a drawing like this of each phase later. And then after you make that drawing of each phase, you are going to, by hand, calculate the center of gravity. Now, of course, there's all sorts of technology that's available now to do it by putting sensors on different joints and having a video of it and letting the computer do the center of gravity for us. However, we are just going to do it by hand because we're going to learn a little bit more about it because we have access to this. All you need is a pencil and a ruler. So here we go. You're going to be following the instructions that are right in the lab. This method is what's called the segmental method because we're going to be dividing the body into segments and doing a little bit of math. So I'm going to walk you right through this. I'm not going to read the instructions word for word. You have them, and you can refer to them as needed as I go through this with you. How we're able to do this, the segmental method, is because we have this information. This is all the information we need to figure out the center of gravity. What someone did, is they took many cadaver bodies and they weighed them. And then they weighed each of these segments. We got 2 of them, right? They weighed each of these segments and they came up with what proportion each segment is to the whole body. So in the average person, and they did this on many cadavers, so we have a pretty good idea. In the average person, the head or neck is 8.2%. If I did the math here and I move that 2 decimal points over, the head and neck is 8.2% of our whole body weight. So if you were to add up all these numbers, it leads to 1. So if we did it in percentages, it would lead to 100. So we're going to be able, by knowing these proportions, to calculate center of gravity, because what is the center of gravity? The point at which there is equal weight above and below it, and equal weight to the right and to the left of it. So it's actually pretty cool, my friends. I have given you an example, okay? So if you're looking for something to use as a reference, here's the example I've given you, okay? So I'm not going to give you the same picture because that would be too easy. But this is what it's going to look like when you're done, okay? By measuring certain distances, we're going to be able to figure this out. And once we get each of these distances, we're able to plug them in to this. Again, using the proportion of body weight. And then we're going to do the math, and then it gives us the coordinates for the actual center of gravity. Okay, so enough of me talking about the intro. Let's get to work. I'm going to use this picture as an example. What the instructions are going to tell you to do, let me just make sure I have this correct. It's going to tell you, let me go back. First of all, it's going to ask you to hypothesize the center of gravity. So use a yellow highlighter to hypothesize what you think the center of gravity will be. So if I was doing this, I might use a highlighter, and I might say, oh, I think my center of gravity is here. So you're going to have your hypothesis. Now we're going to get to work. What it's going to tell you to do, and to make it easier, I'm trying to tell you what to do using different colors, and you'll see that I've used these colors in my example. It's going to ask you, using a red marker or a red pen, to mark a dot at the center of each of these joints. So, I'm going to switch to red, and I'm going to mark a dot where I think the center of the ankle is, on both sides, center of the knee, hip. It's going to tell you the end of the second toe, end of the third digit, center of the wrists, elbows, shoulders, top of the head. And it's also going to ask you to do the 7th cervical vertebrae. So if I were to do that, it's probably somewhere around there. Not obviously in his face, but behind. Then it's going to ask you, let me go back just to make sure I'm doing this correct. We drew dots at the center of each of those joints. Now we're going to use a ruler to draw straight lines, still using the red, to connect these dots. So I'm going to use a ruler. It's important that you use a ruler. I don't have a ruler right here because it's going to mess up the touch screen, but you're going to use a ruler. And we're going to go from here to here, from there to there, as straight of a line as possible. And you'll do the whole thing using a ruler or a straight edge. There we go. On some of the pictures, you can't quite see the joint, so you're just going to have to do the best you can. And again, because I'm using this eye pen, I'm not able to use a ruler, but you're going to use a ruler to make sure that these are precise. All right, and then a ruler from the top of the head to the 7th cervical vertebra. Cool. What does it say next? Locate the center of each segment using a ruler and draw an X. So let's say that I'm looking between the toe and the ankle. I'm going to use a ruler, and let's say that is, I'm just going to make a number up. Let's say that distance is 10 centimeters. So I would mark a line, I'd mark an X at the 5 centimeter line. So you'll do that for all of the segments. Now I'm looking between the ankle and the knee. Maybe it's 12 centimeters in length, so I put an X at 6. Okay? It's important that you measure and that you're precise as possible. I'm just going to fill in what it would look like. Obviously, you're going to measure it out. Halfway point and draw an X. Use a red pen. Now there's one difficult thing, and that is the trunk segment. The instructions are in here. I'm just going to show you. I'm going to use a different color for now. What you're going to have to do is we're going to measure the distance between the hips and measure the distance between the shoulders, and put a dot or some notation at the midpoint. So if the distance between the shoulders is 20 centimeters, I'm going to put a little dot at the 10 centimeter mark. If the distance between the hips is 16 centimeters, I'm going to put a dot at 8 centimeters. Okay? Oh, lost my dot. Now what you'll be able to do is draw a straight line between those two center points. So you're going to draw a straight line between the midpoint of the shoulders and the midpoint of the hips. Then you're going to use a ruler and mark an X at the center. Good, so now we've marked all of our places. Now we're on step number 5. Choose an arbitrary point that will serve as a reference point. Make a large X with the red. If 2 people have the same picture, I want you to choose a different arbitrary point. In my sample, I've put the arbitrary point here. It doesn't matter if it's here, here, or here, because the measurements should still even out. I do have one suggestion for you about making that arbitrary point. My suggestion is to make that arbitrary point obviously not on the body, to the side of it, and kind of in line with the motion. So it really wouldn't make sense, as it's going to make it more difficult if you do it down here. So what I mean is she's running, so it probably makes sense to do it where I put it. You could put it up here, you could put it here, you could put it here, but it's kind of like in line with her running. It could even be down there. If done correctly, though, it shouldn't matter where you put it. So you're going to choose an arbitrary point. Okay, let me thicken that. I'm going to use an arbitrary point that is, boom. Well, that's a really thick one. Then you're going to draw with a ruler these lines that intersect that point. And this is where you pay attention to the X and the Y axis. They're kind of parallel to or in line with the activity. Okay, so if I was going to do this one, I'd probably do a line kind of like this. And then I'd make sure it's perpendicular to that line, kind of like this. Now, as you can see on the practice, I help myself by putting some notations, because otherwise it gets confusing. So I encourage you to do the same. When I look at this is obviously the x-axis. And then this is the y-axis. And I'm going to help myself by putting pluses or minuses. So if I'm looking at the x-axis, we know that anything on this side of the x-axis is positive. Anything on this side of the x-axis is negative. So looking at it this way. For the y-axis, anything above is positive. And then anything down here below would be negative. Okay, now we're ready to start the measurement. Okay, so now we are here. I may have to sneeze, and I apologize in advance. Now, if I were you, I'd switch to a pencil so you can erase it if needed. Excuse me. Excuse me again. And I'm encouraging you to use a dotted line just to make it easier to separate these pencil lines from the axis lines you just drew in solid. So what you're going to do is, from each point, what can I make a pencil line? Maybe gray? Okay. From each of the X points, you're going to draw a line. So if I'm coming from the right leg, I draw a line to the y-axis, and I would draw a straight line to the x-axis. You'll do the same thing for each x. I'm going to draw a line to the y-axis. I'm going to draw a line to the x-axis. These lines, all the lines that go to the x-axis should be parallel. All the lines that go to the y-axis should be parallel. Same thing here. I'm going to draw a line to the x-axis. I'm going to draw a line to the y-axis. And you just go on and on from every single one, okay? Then you're going to get your ruler out and you're going to measure. So let's say I'm looking at this line right here. I'm going to measure the distance from here to there. Let's say it is 4 centimeters. Now I'm going to record that into this table. Now, to help you, you'll see in my example, I wrote this to help. So we're going to now be filling out this column and this column. We're not doing the other ones yet. The distance horizontal is the same thing as the distance from the y-axis. So distance horizontal is the distance of the horizontal lines. Wait a minute. See, you got me all confused here. Distance from the y-axis, yes. So the distance horizontal are the horizontal lines, or in other words, the distance to the y-axis. So if that's 4 centimeters, and we're talking about the right foot. So this is going to be distance horizontal, right foot. Distance horizontal, right foot, 4 centimeters. Right? Because this is distance to the y-axis. And then that means this is going to be distance to the x-axis. So on that same picture, now I'm going to look not at the distance horizontal. Now I'm going to look at the distance vertical. So I'm going to measure from here to there. Let's say that is 8 centimeters. That's right foot, distance vertical. Right foot, distance vertical is 8 centimeters. You will see on my example, sometimes what I did to help myself, I encourage you to actually write your values here. So in case you have a question or maybe you messed up, you know where to look again. Remember, these measurements are always going to be in centimeters. What I've also done, because in this one it can be a little hard, I help myself by notating right or left, leg or arm, just so I could remember what I'm looking at. And you're going to keep doing that, measuring for every distance horizontal and for every distance vertical until you've filled out this whole thing. After you fill out the whole thing, now we're going to do some math. Now you're going to take each number and multiply it by the proportion. I don't have my calculator with me, but bear with me. So I'm going to take 4 times 0.0143. Let's say that's 2.2. I'm just making numbers up. I don't have a calculator at the moment. Now I'm also going to take 8 centimeters times 0.0143. And let's say that is 4.6. See how we did that? So you take each one, multiply it by that percentage, and put it in the next column over. Take this one and multiply by the same percentage and put it in there. When you are done, you are going to add up all of these numbers. You're going to add up all of these numbers. Now, pay attention to the pluses and minuses. Let me go back here. Let me revisit some of these numbers because I forgot to talk about pluses and minuses, and I apologize for that. If I'm looking at, what did I say? Let's see. I'll use red. I said this was 4 centimeters. So the distance to the y-axis is 4 centimeters. Distance to the y-axis, distance horizontal. Would that be positive or negative? Well, I'm looking at the x-axis, but I'm in positive land. So that 4 is positive. However, the 8, if I look at the y-axis, this is actually below. So this would be negative 8. So actually, when I put this in here, this is going to be negative 8. Negative 8 times 0.0143 is negative 0.46. Use the example to help you. A lot of them are going to be negative. Some will be positive. So when you do the math, keep jumping around. So when you do the math, I'm going to do, 0.726 plus 1.733 plus 0.126 minus 0.08075 minus 0.05005. Or you could do plus 0.05005 and then add a negative sign. I think it's easier just to add them in the positive numbers, but when I get here, it's going to be 0.126 minus 0.08. And you go all the way down, and then you'll get your sums. I would do that a couple times to make sure that you got the right number. These become, folks, your coordinates for the actual center of gravity. Negative 4.7, 2.7. Negative 4.7, 2.7. So I'm going, let's see, use a different color here. So I'm going 2.7 up from here. And then I'm going negative 4.7 in that direction. Where those coordinates come together, so it's up 2.7 over 4.7, that is your calculated center of gravity, and I've highlighted it in pink. So when you're done, you're going to be able to compare your hypothesis to what's your actual center of gravity. So maybe my coordinates tell me it's actually right there. Okay? And at the bottom, I might write calculated center of gravity. And then I would put hypothesized. So, folks, this isn't necessarily hard, but if you haven't done it before, it's easy to get confused. Your center of gravity should make sense, right? It's possible that your center of gravity may not actually be in the person. The best example of that might be the high jumper. It's possible that this dude's center of gravity is here. Okay, so it might not be in the person. All right, so there you go, my friends. I've given you examples. If you have questions, ask. Please do this well because you're going to be doing this again 4 times over for your lab project. And I'm going to look at these and I'm going to make sure that they were done correctly. So take your time, ask questions if you have them. Off we go.